Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we're going to look at a concept in integrand of vectors, and these are going to give us a general illustration for, of course, other areas that we're going to discuss for the line integrals, surface integrals, and volume integrals, which are going to have different applications in various areas of course, electromagnetism and other aspects that we're going to describe using these vector integrals. So in this specific aspect, I'm going to use this particular illustration of a vector that is going to depend on a single variable whose elements are continuous in a particular interval. So in my case, I'm going to have this specific vector represented by R, whereby R is going to be a vector that is going to be continuous and being represented by elements of R1 U I plus R2 U J plus R3 U K, where I, J, and K are vectors and vector components in those specific direction for I, J, and K given as such. So we can be able to consider an integral of such a kind of a vector by giving it as the integral of RU du being given as the respective elements that are continuous in this specific interval, whereby we're going to have I for the integral of R1 U1 du plus J, the integral of R2 U du plus K, the integral of R3 U du given as such, where I, J, and K are vector components as mentioned earlier. So this is going to be referred to as the indefinite integral of this specific vector Ru that we have given. And if there exists another vector that I'm going to perhaps give as Su, which is of course a derivative, or rather which is going to form where Ru is a derivative of this specific vector, then we can be able to illustrate this specific relationship whereby perhaps Ru is equivalent to d over du s u, and then given as such. So we can be able to illustrate, or it's not going to be, so this is a derivative of this, so this is going to give this is a derivative of this, so this is going to give a relationship that exists between this specific vector of Su that has a relationship with this specific vector that is depending on a single variable with specific elements that I've mentioned on the board. So we can be able to illustrate the integral of this specific function of Ru with respect to S, whereby we're going to have the integral of Ru du can be given as the integral of du over d over du s u given as such, and this is going to be given as the integral d over du su du given as such. So from the general illustration of our integrals, we had said that this is going to be give us, of course, the product over su plus an arbitrary constant, which is independent of this specific vector u, which we have said. So that generally this is going to give us a general integrand of our vectors and how we can be able to illustrate it. Now this is going to be applicable for indefinite integrals. Now in our discussion of the definite integrals, we say that definite integrals consist of vectors, or rather the integrals which have got what we call the upper and lower limit of the integration, and we can be able to give a specific form of this specific definite integral in terms of this integrand of vectors which we have given in a general form. So if we have of course the limit for the upper limit over b, and then we have a lower limit of integration over a over this vector, so this is a lower limit. So in this specific sense, I mean that there is this vector is over the limits of a and b. So generally, if we have an indefinite integral that is going to be represented using this specific form, so therefore we can just have a set of representation for these specific vectors of r, for Ru du being represented as such. And if we're going to give of course an answer for this, we had said that this can be written as in form of a vector of this S whereby we're going to have d over du s u du given as such, and this is going to give us, of course, the integral of this specific function plus c from the lower limit to the upper limit. So we can be able to do a substitution for that one, and that is going to give us sa plus c minus, also this from the upper limit, so it's sb minus sb plus c minus sa plus c respective. So if we try to look at this and put the right terms together, then we're going to have sa minus sb plus c minus c, which is going to give us the general equation for the integral of that specific order. So this is going to give us a general way in which we can be able to represent the definite and the indefinite integrals of our vector forms of single variables as I've given for Ru, which of course are going to assist us in trying to find the line integrals, the surface integrals, and volume integrals insofar as integral calculus is concerned. And this, of course, we are going to appreciate them whenever we are going to do some of the applications that are going to follow, of course, which are going to assist us and evaluate different scenarios of applications of this aspect of vectors. So catch us in our next video, so we're going to look at the concept of line integrals and then volume integrals and surface integrals respectively. So that is it for now, guys. Bye. God bless you.